To find the derivative of the equation 2x to the third power plus 3y squared minus 4x plus 5y equals 1 with respect to x, implicit differentiation will be required. What we're going to have to do is take the derivative of each term, and as we're taking the derivative of each term, we'll remember to be differentiating with respect to x. And what that means is if there's a variable other than x involved, we'll have to differentiate implicitly. Let's begin. Term by term, the derivative of 2x to the third. Well, that involves an x. That's the variable we're differentiating with respect to. The derivative of 6x to the third or 2x to the third power is 6x squared. The second term, 3y squared, does not involve an x. It involves a y. So when we take the derivative of 3y squared, that's 6y to the first power, but we're going to have to chain on a factor of y prime. Anytime you take the derivative of a variable other than x in this equation, we're going to have to include a factor of y prime, which is the derivative of y with respect to x at the end of that term. The derivative of negative 4x is simply negative 4. We're differentiating with respect to x here, so the derivative of negative 4x is negative 4. The last term, 5y, again, does not include an x. This is y, and if we're differentiating with respect to x, we can take the derivative of 5y to be 5, but we're going to have to include a factor of y prime. On the right side of the equation, the derivative of 1 is simply 0. So our derivative now has 4 terms. 2 of those terms involve a y prime, and 2 do not. We want to find the derivative of y with respect to x, which we're representing the derivative of y with respect to x with y prime. We have to isolate y prime in this equation, and that's simple algebra. It's going to be 2 steps. The first step will be to move the terms that do not have a y prime, in this case 6x squared and negative 4, to the left side of the equation. So I'm going to leave the terms that do involve a y prime on the right, in this case 6y times y prime and 5 times y prime. And I'm going to move the terms that do not involve a y prime over to the right side. So I'll have to subtract 6x squared from both sides and add 4 to both sides. And we now have all of the terms that involve a y prime on the left and the terms that do not on the right. Next, all of the terms on the left involve a y prime, because that's how I set this equation up. I'm going to factor a y prime out to the front. Y prime times the quantity of 6y plus 5 is what the left side of the equation becomes if I take a y prime out of each term. The right side of the equation is negative 6x squared plus 4. Often if you have 2 terms and one is positive and one is negative, you'll see the term that is positive written first. Those variables could be written in either order, but I'll write them as 4 minus x squared, since the 4 is positive and the 6x squared is negative. The final step to isolate y prime, to write this equation in the form y prime equals, is to divide both sides of the equation by the quantity of 6y plus 5. That will serve to eliminate the 6y plus 5 quantity on the left side of the equation and leave this derivative in the form y prime equals, and in this case y prime equals 4 minus 6x squared all over 6y plus 5.